today we're talking about multiplying and dividing rational expressions. So we've already gone over how to factor and then how to simplify rational expressions. And now we're going to take it a step further and use both of these skill sets to multiply and divide rational expressions. So first we're going to start with a discussion of how we multiply and divide rational numbers. So another way of calling, another thing that we call rational numbers are just fractions. So in discussing how we do that with just numbers, we should be able to then extend it to how we do it with rational expressions. So something that looks like this. It's very ugly. So we want to be able to reduce it before we actually multiply it. Okay, so that's basically the gist of what we're doing today. And again, you're not going to be really using this yet in any word problems. That's saved for advanced functions, but we learn the methods that we need in functions so that we're ready for next year. Okay, so we're going to multiply and divide rational expressions by first reducing them to their lowest form. And then, of course, we need to include the restrictions on all multiplication and division questions. So first we're going to look at the numbers, because expressions are just polynomials, which are just can be treated like numbers. So whatever we can do with numbers, we can do with the polynomials. To multiply rational numbers, multiply the numerators and the denominators. Okay, so in this case, we multiply 2 times 4, which gives us 8, and 3 times 5, which gives us 15. Okay, just multiply the tops, multiply the bottoms. In this case, we imagine a little 1 over the 2, under the 2 as a denominator, so you have 10 over 7. Okay, if you are able to, it's simpler to reduce the fraction before multiplying. Okay, so with this fraction you have two options. Either you can just go straight across and get 6 over 12, but then you'll have to further reduce that to a half. To make your life easier, you can reduce before you multiply. So to do that, you can look top to bottom, or you can look across the multiplication line. Okay, so 3 and 3 is divisible to just 1 and 1. 3 divided by 3 is just 1. And 2 divided by 4 is just a half. So you're dividing both of those by 2. So now you just get 1 times 1 and 1 times 2. Okay, so it's simpler to do that reduction before you multiply. Same case here. 4 and 5 can't, 4 and 11 can't, but 5 and 10 can be. So if you divide both of them by 5, you get a 1 and a 2. So you have 8 over 11. This is nice because your final answer is already in lowest form, so you don't have to do reducing after you have the multiplication. And before the multiplication, the numbers are smaller and simpler, making it easier for you to do in your head. You don't have to take out your calculator as often. Here, 4 times is 6. There's a 1 there. These are both divisible by 2 to make this 2 and this 3. So you get 2 times 1 is 2. 1 times 3 is 3, 2/3. Okay, so that's multiplication. Remember to divide fractions. You just multiply the reciprocal. Okay? So another way of saying multiply the reciprocal is to flip and multiply. So in this case, it's 1/3 times, and then the 3/4, you just switch top and bottom, 4 over 3. So then you see if you can do any reducing, okay? You cannot reduce these 3's here before, you flip to multiplication, okay? You could only do reduction when you have multiplication. So there's nothing I can reduce, so I get 4 over 9. Here, 1/2 times, now this is technically 3 over 1, so the reciprocal of 3 is 1/3, so you get a 1/6. And here we get 4/5 times 3 over 2. Now you'll notice that you can reduce the 4 and the 2 to a 2 and a 1, so you get 6 over 5. So now let's actually do it with a rational expression. So the same rules apply, but we want to reduce first, okay? It looks really ugly like this. That would be a very difficult algebraic task to actually go through and multiply that. So what we want to do first is factor the numerators and the denominators. That will tell us what we're able to reduce, which we learned in the last lesson. So we factor x plus 2, x minus 2, okay, all over x plus 6. Now I'm going to write x plus 6 twice just to remind myself that that's what x plus 6 squared means. You don't have to do that, but I'm going to do that in this case. Then what multiplies to 18 and adds to 9? So that's x plus 6, x plus 3, all over, and then this can't be factored. It's still 2 times 2 minus x. Okay, now we want to reduce by dividing out any common factors. So I call this, now it's time to slice and dice. Okay, so you can get out your slicer and slash away. So this, anything that's on the top can be slashed with anything that's on the bottom. So x plus 6 and x plus 6, but notice you can only take one of them. Sorry, the marker is not very dark. I'll get a different one. Oh, there's that one. There we go. Okay. Now, there's no x plus 3 on the bottom, and there's no x plus 2, but what about this x minus 2 and this 2 minus x? Okay, recall from last lesson that that reduces to negative 1. So if you forget why that's true, go back and watch that lesson. So you'll see we're left with a negative 1 on the outside, which you can just use a negative, or if you want to write negative 1 there, you can. X plus 2, x plus 3, all over 2 times x plus 6, okay? Notice I put the constants out front. It just looks better. It's more proper. So this 2 I put out front, and this negative 1 I put out front. And you know you're done when there's nothing further to reduce. So you multiply the numerators and denominators. So just put them together, multiply them together, and then write it as a single expression. Okay, now you could, if you needed to, foil this if you wanted, but it's usually fine to just leave it like this unless I say to expand it at the end. So then you have to include restrictions, okay? This is the part that a lot of people forget. So highlight this, star this, whatever you need to do. We need to include restrictions. And remember from last class that restrictions include any of the original denominators from the very beginning, okay? So we can't just look at x plus 6, okay? So x cannot equal negative 6, but then we also have to look at this factor. So x cannot equal 2 either. Okay, so anything that would make any of the original denominator 0 is a restriction. So that's multiplying. Dividing is a bit different. Okay, dividing is a bit different because you have to do the whole flip and multiply thing. Okay. So, first we want to rewrite as multiplying the reciprocal. Okay, so the first thing we want to do is this 21p minus 3p squared. Actually, you know what? I kind of have changed this order. I'm going to switch these two. We're going to factor first, okay? Just because it's a bit of a waste of time. So this is the common factor. We can common factor here. We can take out a 3p, and we're left with 7 minus p. Okay, on the bottom we can take out a 4p, and we're left with 4 plus p. Okay? Divided by, okay, so this is, I don't like the order it's written in. I'm just going to think about that as p squared minus 9p plus 14. So you have p minus 7, p minus 2, all over p plus 6, oh sorry, no, p plus 3, p plus 4. Okay, so you cannot slice and dice yet though, because it's division. You can only reduce when it's multiplication. So now we have to flip the second expression and turn this into multiplication. So you have 3p times 7 minus p all over 4p times 4 plus p times p plus 3, p plus 4 divided by p plus 3, sorry, p minus 7, p minus 2. Okay? So take a look at that. So now you can note any of the restrictions, okay? Now, this is what's confusing because you have to include anything that ever was a denominator. Okay, so the restrictions are going to include, obviously, this p, this 4 plus p, this p minus 7, and this p minus 2, but they're also going to include the p plus 3 and the p plus 4 because they were in the denominator before we did the flipping. So you just have to remember that the restrictions include anything that was ever in the denominator. So that is another change from multiplication. So the two changes for multiplication are that there's more restrictions and that we have to flip and multiply. Now it's just a multiplication question and we can just do it as we did before. So these p's cancel out. This p minus 7 and 7 minus p give us a negative 1. And 4 plus p and p plus 4 are the same thing, and so they cross out. So we're left with negative 3, bracket p plus 3, all over 4 times p minus 2. Okay, so 3 is negative because of this negative 1 with this crossing off there. Okay, so that's your final answer. And you have to, state any of the restrictions. So you get p cannot equal, okay, 0, negative 4, negative 3, negative 4, but we already have that, 7, and 2. And those are the restrictions. Okay, so you've seen one example of multiplication and one example of division. So I do encourage you at this point now to go ahead and try some of the examples. See if you're able to do any of them without watching me go through them. So I encourage you to pause this video right now and try that, but I will go through and do the examples. Okay, here there's nothing we can factor. It's all just a bunch of x's and a bunch of y's. So you just have to kind of look at what you can reduce. So I look at the numbers first. So this 6 and 8, they can both be divided by 2 to give me a 3 here and a 4 here. And then the 5 and the 15, again, a 3 here and a 1 here. So I did the numbers. Now I'm going to look at how many x's there are. Really, there's 1, 2, 3 total x's on the top and 1, 2 x's on the bottom. So these two cancel out, we're just left with 1 x on the top. Then I look at how many y's I have. I have 3 y's on the top and 5 y's on the bottom. So this is going to completely cancel out, and this will still just be left with 1. So I'm left with 2 y's on the bottom. So 3 times 3 is 9. And we still have an x all over 1 times 4. And then there were still 2 y's, so 4y squared, where we have x cannot equal 0 and y cannot equal 0 as our restrictions. Okay, this example is a little bit confusing because there are a's and b's. So I don't know if you remember this trick that I taught you before, but the best way of doing this, and you can factor it on the side here, is let's say you take something like this. Let's call it number 1, and I'll factor it over here. I like to rewrite it with only a and keep the b out of it, okay? So then I factor that, and remember you just use decomposition to do that, and that factors to 5a plus 1, a minus 3, okay? And once you've done that, you can just add the b to the second term of each of the factors. So I add the b back in, and that just becomes 5a plus b times a minus 3b. Okay? So again, you just take out the second variable, pretend it's not there, factor it with only one of the variables, okay? And then add the second variable in to the second term of each of the binomials. Okay? You can FOIL it to make sure that it works, but that is right. Okay, so using that same method, you just go ahead and factor this. So you get 5a plus b over times a minus 3b. All over, when you factor this, you get a plus 2b times a plus 2b. Just going to erase this so I have enough room. And then I get, this is just stays as a plus 2b up here, and that can be factored to a minus 3b and a minus times a minus b. Okay, so now it's multiplication, so I can start crossing off. So a minus 3b, there's two of those. A plus 2b, that, and that's it. So I'm left with 5a plus b over a plus 2b and a minus b. Okay, so a cannot equal, in this case, negative 2b, again, negative 2b, positive 3b, or b. Okay? So again, I'm just rearranging for a.